Hello, welcome to the video. In this question, we're asked to calculate the slope of a line. And we're given 2 points, and these points are a little fancier than we sometimes see. These points have decimal values. But we're still going to approach the problem using the same formula that we could have used if they were round numbers, which is that slope formula, y2 minus y1 divided by x2 minus x1. And I like to set it out, and now I'm going to put my parentheses with the subtractions in the middle because in the numerator I'm going to be subtracting 2 values. And in the denominator, I'm going to be subtracting 2 values. And now let's plug in what those values will be. So first, I like to label the values very clearly in my original problem. Here is going to be my first x and my first y. And then here is my second x and my second y. And now I can go ahead and plug them in. The first thing I need to plug in is y2, so that was 8.49. And below that goes x2, which was 8.5. And now I'll plug in the coordinates from my first point. I'm first going to plug in my y1 value, which is a negative 0.37. Make sure that decimal point shows up. And my x1 goes down here, and that's a negative 4.4. So I'll plug that in as well. Just taking a look at this, I notice that both in the numerator and denominator, I'm subtracting negative numbers. So I'm going to rewrite both of those. I'm going to rewrite that as a plus, and I'm going to rewrite this as a plus. So let's rewrite that problem now. And I've got 8.49 plus 0.37 on top. And in the denominator, I have 8.5 plus 4.4. So if you'd like to pause the video for a second, put those into your calculator. When you add together 8.49 plus 0.37, 8.49 plus 0.37, we're getting there 8.86, and don't worry too much about having a decimal in the top of your fraction just yet. Let's finish our calculations. In the bottom, we have 8.5 plus 4.4, which gives me 12.9. Now, we don't want to leave our final answer as a fraction with decimals in the numerator and denominator. That's not really proper. So one thing we can do is convert these into whole numbers. Remember what we know about like fractions. The value of the fraction will remain unchanged if we multiply the numerator and denominator by the same value. So let's think carefully about what value to multiply them by. The denominator has only one decimal digit, so that's in the tenths place. So we could get rid of this decimal by multiplying by 10. But the numerator has 2 decimal digits, so that's the tenths and the hundredths place. So to get rid of this decimal, we'd need to multiply by 100. Since we have to do the same thing to the top and the bottom, let's multiply them both by 100. Showing my work there, I'm multiplying the top and the bottom by 100. So the value of the fraction will remain unchanged, but we won't have to look at those decimals anymore. So 8.86 times 100 gives me 886. Feel free to do that on your calculator to check. And 12.9 times 100 gives me 1,290. So my fraction's looking a little, little bit better there. But we always want to give our answer in simplest form. So the next thing I want to think about is, can I reduce this fraction at all? In other words, is there any number that I can divide both the top and the bottom of the fraction by? And just looking quickly at it, I see that they're both even numbers. So I know right away I can reduce the top and the bottom by dividing by 2, since they're both even. So I'll divide by 2 up here and divide by 2 down there. So let's look at what we get when we do that. 886 divided by 2 gives me 443 in the numerator. Oh, sorry. There we go, 443 in the numerator. 1,290 divided by 2 gives me 645 in the denominator. I'm looking at that, and nothing else jumps out at me that I could divide it by, but those are some big numbers. If you'd like to be sure, one thing you can do is put that fraction into your calculator if you're using the TI-30, and it will reduce it for you to simplest form. So in fact, if we even go back here when we had this fraction, we could put this in our TI-30 and ask the TI-30 to reduce it to simplest form. Notice I couldn't put this in the TI-30 won't like it if I put in a decimal in the numerator and denominator. It will give me an error message. So I need to use this step by hand. But then I could take this version of the fraction, 886 over 1290, and enter it in the calculator in this way. So if I'm using the calculator, I'm going to first type in the numerator, 886. Then I'm going to hit the key. I call it the ABC key. It looks like this, ABC. That lets the fraction know, the calculator know, hey, the number you just entered is the numerator. Then I hit the ABC key, and then I enter my denominator, 1290. I'll pull up the calculator in a second so you can see what that key looks like. But if I enter this in my calculator, the answer, or the output it should give me, it will give me in fact, is 443, and then a little L, and then 645. And what that's telling me is that the most reduced form of this fraction is 443 over 645. So that's the slope of this line. So that's quite a fancy slope there, but just take it one step at a time. Pay attention to details and you'll get there. Before I address the last part of the question, let me just show you a picture of that TI-30 calculator. Oh, did I lose it? Sorry, hold on a sec. Okay, there it is. So here's a picture of the TI-30 calculator. If you look right here, there's that ABC key that I'm talking about. So that's the key you would use to tell the calculator you're entering a fraction. So you type 886 ABC and then 1290 and then hit enter, and that would give you the output I was talking about. All right, let's go back to our question and finish it up. So we're back at this question. They're asking us about the slope of the line, telling us what does that tell us about what the line will look like. Notice that even though this is a pretty ugly, let's say, fraction, it's a positive number. There's no negative signs on the numerator or the denominator. So the slope of the line is positive. So that tells me that the line I'm looking at is an increasing line. The line is increasing, which is another way of saying it's an uphill line. If I were a person standing on that line, moving from left to right up the line, I would be walking uphill.